This is section 2.5, reasoning using properties from algebra. This is the first section where we're actually going to prove things. So this is actually something totally brand new, and it's going to change everything that we do in here going from this point forward. We're going to review our algebraic properties of equality. So A, B, and C are real numbers. The addition property of equality, that's what this POE stands for, says that if you add something to one side of an equation, you must add the same thing to the other side to keep it balanced. You've been using this property for years. As long as you've been in math in middle school and high school, you've been using this property. Now, there's also a property of equality for each other operation: subtraction, multiplication, and division. So if you have an equation and you want to subtract something from one side, you have to do it to the other side as well. That's all that means. So there's also one for multiplication and division. The last property of equality here is for substitution. When two things are equal, you can replace one for the other in any equation or expression. So you're going to see on the next slide where these come into play. So we're going to write reasons for each step. We're going to solve this equation, 2x plus 5 equals 20 minus 3x. Write a reason for each step. So right now we have 3 columns set up. We have our equations, we have our explanations, and then we have some reasons. And these reasons are going to be our algebraic properties that we just talked about. So how do you know that 2x plus 5 equals 20 minus 3x? This is going to be our first step for a long time when we're talking about proving things. The reason that we know that's true is it's given to us. They give that to us to start. So we call that our given information. They gave it to us. Now, if this is true, how do we know that this is true? This is where that middle column helps you. We have 2x plus 5 equals 20 minus 3x, and then all of a sudden we have 5x over here. So how did 2x turn into 5x? And where did the negative 3x go from the right side? Well, eventually we're not going to be showing this work here, but what you really did was you added 3x to each side, because when you add 3x to negative 3x, it cancels on this side. And when you add 3x to the left side, you end up with 5x. So this is telling you what you actually did to both sides. Now, what is that called? What's the property if you add something to both sides? It's addition, property of equality. So we're going to use that abbreviation. If you want to write it all out, you certainly can. But this is shorter, it's quicker, it's going to save you some time. You just need to know what it means. Okay, so we started here. Now we know that this is true as well. Well, we need to solve this for x. That's where we're going. That's our plan. So what could we do next to get a little bit closer? They show you in the next step down that if 5x plus 5 equals 20, then 5x equals 15. Well, how did you get 5x by itself? If you're showing your work, you're actually subtracting 5 from both sides. That's why we just have a 5x on the left, and 20 minus 5 is 15. So the middle column tells you. If you couldn't see how you got from here to here, the middle column will tell you you're subtracting 5 from each side. What's that called? Subtraction, property of equality. When you do it to both sides, that's the property of equality. Now, we almost have x by itself. If this is true, how do we know this is true? What are we doing to both sides? Tells you here. You're dividing both sides by 5. So using your division property of equality, we know that x equals 3. Okay, so this is the first proof that we've done in here, and we're going to do lots more.